Hey everyone. Hopefully I'm audible. Let me know if you're sitting in the chat and you can actually hear me or not. But I am going to be streaming for a good amount of time today. Probably actually longer than my normal stream. We'll see. We'll see how long and how ambitious I get on this. But yeah, the idea is to take a much longer video doing kind of a whole project and maybe in the future edit it down to a much more watchable 30 or 45 minutes or an hour kind of video. My inspiration there is Adam Savage's one day builds, which are super cool if you haven't seen them. But he basically builds one thing in the shop. And yeah, so I'm going to try that. Feel free to drop in and out, but let me know if you're around and say hey. I'll probably actually turn my camera off and just show the screen, so it'll be kind of quiet in the background. Maybe I'll see if I can get some audio going as well. But I don't know. Otherwise, I might just be quiet and it'll just be a video cut, and I'll jump on every now and then to explain stuff and then jump off so I can work on stuff. So if you're not sticking around for the whole thing, no worries. Otherwise, come say hey, and I'll probably jump on if anyone asks me any questions or anything. So what I'm doing today is let me go ahead and just full screen this. So I'm working on the SPI protocol for Anachro-PC, which is my PC architecture of the anachronistic future. The idea is to have a bunch of microcontrollers be a PC. And for that, I wanted a decently fast protocol, which is why I chose SPI. But I need to build this protocol first. So something like the layers are going to look layer diagram. So the lowest layer, which is physical, is going to be something like SPI, and then a GPIO, and then a GPIO. Where this GPIO is going to be a, well, let me just CPO, or what is it? Controller out, peripheral in, peripheral out, and clock. So there's going to be 3 pins there. Then there's going to be one GPIO, which I'm calling ready, which is essentially the signal from the component. So like your keyboard would say, hey, I have something to send. And then we have another GPIO, which is go, which is basically the arbitrator saying, yes, keyboard, I am ready to listen to your message. Above that, we have, I don't know, let me pull up the OC diagram, but try and use vaguely. Yeah, data link is going to be Hobbs encoded data, and then some state logic for this part. I don't know, maybe I don't want to use these names, but let me just use this for naming. Then I'm gonna have Saturday postcard encoded data. And then the next layer is what is this? This is going to be the macro ICD data types. So I have a crate called Anachro-ICD that has all of the actual Anachro protocol. Then above that, let's see, I have like macro session state. And then above that, we have application data. So like a 6-layer system. Probably this is comfortable to call application. This would be data. This actually probably is more also application. I'll keep it separate for right now. This is, or yeah, I guess this is presentation for using the OSI terms. This is probably more, no, this is session, I guess. This would be something like, I don't know. I should stop using the OSI terms because I'm just going to confuse myself. I'll come up with terms for these later. If there's anyone in chat, definitely send me a message and let me know if you can actually hear my audio, because I don't think I have. Well, it should work. It's using my audio. Hello, hello, hello. Yeah, it's working. Okay. So yeah, I'm just gonna call that this for right now. But what I'm gonna be working on today is essentially this. I'm gonna be working on this. I already have these really working. So it's basically these I'm going to be working on today, and I'm actually going to be working on this first and this second, because I'm actually going to do this in a simulated world to start. So I'm actually going to do this over a TCP connection. So today, let's see, 2020, 09, 19, 19 stream. I'm roughly going to be working on that was code or Enc logic. Sure, that's good. Work on Enc logic as a crate. Get Enc logic working over TCP simulator. Then get physical layer working, maybe embedded HAL, at least for part of it. I'm going to be using both a SPI controller as well as a SPI peripheral, and there's not really an embedded HAL SPI peripheral trait because it's much more event driven and harder to do, but I'll probably make it work at least for the SPI controller part, because I think more people are going to be writing components rather than the arbitrator itself. So I'll at least make that easy for people. Yeah, and then get it working on 2 actual physical NRF 52840s. So this is like the main goal. We'll see if this is a whole day of work or more than a day of work, but my goal is to have that working by the end of today. I may take some breaks and stuff in there. Ooh, that's fancy. That's not what I want at all, though. This is what I want. So yeah, like I said, I'll probably talk a little bit, especially when I'm getting started. But then once I kind of hit a development stride, I'll probably go quiet and just drop off the stream. I don't think there's a good way for me to share audio. Well, let me try real quick. Let me just find one track and see if this works. And if it doesn't, then oh well, sorry, it'll be quiet today. Let me open these. It also helps if I actually connect my Bluetooth to So now I have audio. So let me stop sharing my screen and start sharing my screen. I think, yeah, I can only share my screen. Can I do multiple things? Share. No, because that stopped sharing my screen. Oh well. Yeah, so you won't have music, so it'll be quiet when I'm not talking, but maybe I'll add that in post. But yeah. Sorry it'll be quiet, but I'll jump on. Like I said, if you want something answered, just ping me in the chat, or I'll just work on whatever I feel like. So let's go ahead and get started. I'll leave this up for a little bit. Let me see if this is fairly reasonable. Yeah, that's fairly reasonable, I would think. So I've created an empty crate. So we're going to be working in that. So cargo check. It's going to be like, yes, it is a totally empty crate. So instead, actually, I'm going to disconnect this, and I'm going to listen to it on my phone so I can unload my my poor overworked laptop. Bluetooth. Let's listen to some audio. Okay, so I need to work on the encoding logic. So I have some of this already kind of described out, where I have physical components, and this is kind of what I described below. I have misc notes. This is essentially the messaging sequence. So kind of this is my state machine. So I really need to build a state machine. Then yeah, maybe I'll start with just a trait because that'll be easier. And if it gets hard, then I'll just make it a struct. Go line. Yeah, I think I'll start with a trait because that'll be easier. Okay. But I kind of want that to be a private API. Okay, well, let's start with it as two different things, and we'll see where it goes. Okay, so let's trait. What did I call this? Enc logic. Level. Wanted. The high level is gonna have something like in Q. let's see. I'm gonna paint myself into a corner of zero copy shenanigans. Whatever, let's just do. Maybe I want this to be an option. I just never know whether I want to just do a result with an empty packet or not, or if I want to actually have like a layered. Whatever. Let's see, is there anything else I need to do on the logic level? Because if I'm actually looking at here, I'm basically just encoding data in and out. I might just need like a. I actually probably need separate traits for controller. The high level may not, but the low level is definitely going to have different ones. Okay, and then from a low level, from a component perspective, we're going to have pull let's see. High level is fine. Russ needs something like a raw slice or something like that. What do I want to do when you I'm going to drop my camera off and just share my screen, so feel free to watch. Again, if you have any questions, feel free to hit me up in chat. Sorry for the silence. Maybe I'll figure out how to route audio in another time. Okay, so I'm checking back in because I've made some progress here. Originally, I was preparing different methods for sending and receiving, then I realized that SPI is synchronous and it doesn't make sense. So I've just renamed everything to exchange, and there's really only one method for this. So I've got for the component side of things, the component is allowed to set that they are ready or clear that they are no longer ready. Let's see, should this abort transaction exchange? Probably. They can mark the ready as clear. Query whether the go line is low. Well, no, maybe not. So is the arbitrator ready for data? Preparing an exchange. So this is something that you can do to say, okay, I'm presetting the data that I'm about to send. So this is essentially like preloading a DMA transaction, but not triggering it. Triggering it actually triggers a DMA exchange. This is set as long as the exchange is still active. Complete the exchange means attempt to successfully complete the exchange. So if we're completed, then we get an okay. Otherwise, we get an error. Abort is similar, except for it will terminate a connection. So like stop the DMA transaction if there is one in progress. Yeah. And then on the arbitrator, it's basically the same, except for we swap the go and the ready lines because that's how the protocol works. Is they're basically kind of like clear to send, ready to receive kind of things, if you're familiar with a UART, except for I'm using them for negotiating SPI transactions and things like that. So yeah, otherwise the sides are basically the same because I expect both sides to essentially be doing DMA transactions. So that's why I have separate like prepare and trigger, because you're going to actually be calling that in a callback that, so for example, like on the component side, probably firing that up to an interrupt so that yeah, like when you get something like a like the ready line goes low, then you have like a callback that triggers the SPI exchange. There's some stuff like on the NRF52 where there's a possibility to shortcut that with no CPU interaction. But for implementing that, I probably still want to update tracking variables or something like that. So we'll see. I don't know. We'll see once I start implementing, but I think this is a good place to start. So now I still think the high level logic is still going to be basically the same, except for I'll have a state machine that's walking through this. We'll see. We'll see if I can keep my symmetrical API here. But yeah, we'll see. Okay, well, I'll go back to working some more, and if you have any questions, feel free to ask me in chat. I think there's only one person hanging out here, but we're listening to good music. We're working. That's pretty good progress. So I'm gonna go ahead and get back to work. Hopefully the music sounds okay and you enjoy Lu's song. I do. Okay, so it's been a little bit, but right now I'm setting up my microphone. Right now I have kind of a basic TCP server that's going to essentially simulate a SPI connection, and right now I just have like the very basic of like handshaking happen. So the first thing that they do is they send their go state or their ready state, depending on who they are, just so the other one has context. Then I need to make it actually emulate this. And the reason that I'm doing this again is so that I can prototype this much faster than using actual hardware. And then ideally, whatever I do will be pretty quick to just port to physical hardware instead of TCP. Right now, I'm spending a little bit of extra time building this like SPI simulation layer, but it will probably come in handy later because I do eventually want you to be able to, as a developer of Anachro, to have a fully simulated TCP connections. So you could have like the arbitrator and then like 4 simulated devices, so you can prototype stuff fairly rapidly in a total like no hardware situation, but then later move it to hardware without having to like re-implement logic and stuff like that. There'll still be some like porting the connection stuff to your specific hardware, but the idea is that if you have like a simulated display or a simulated whatever, you can play around with that. And if I get far enough, I'll actually maybe try prototyping that, where I have like a simulated display over TCP that just renders some text to the screen, pretending to be like a little one of these little like 2x20 displays or something like that, so I can pretend to have a device. But it's going well. Managed to get my connection in first try. I'm doing COBS over TCP because I don't have framing over TCP. So I'm going to end up doing something like COBS encoding twice, which is kind of gross, but whatever. It's a PC. It can handle it. And it'll make my life easier later. So what I'm doing, just as a quick reminder, is essentially I'm bringing up these 2 layers. So like the physical layer is actually going to be TCP, but it's SPI emulated TCP. So that's what I'm building with this little state machine. And then after that, I'm going to build kind of the high level logic that goes on top of that, that says like, oh, I have a packet to send, request to send. Oh, arbitrator says, yes, it's your turn, and then goes for it. So I'm going to be building a little bit more of this and then start working on this, and then implementing those traits that I wrote earlier that will let it act like just a totally normal connection or whatever. And then once that's working, I'll probably build a little bit of an example on top of that. And then once that's working, I'll go and get, well, I have my NRF52 boards here somewhere. I will go pull them off of my shelf. Ferris did a company retreat lately, and I brought like all of my hardware. So they're still in the bags that I brought back from there. So I will have to go for 5 or 10 minutes and unpack that, but I'll probably need a break then anyway. So for the folks that are popping in and out, thanks again for watching. I know I'm being kind of quiet. You're just listening to music, but hey, we'll see how this goes when I actually edit this down to only the parts that have my face in it, and then maybe super fast forward of me writing the actual code. We'll see. Maybe it'll be something. Maybe. Okay, I'm going to get back to work.
fine days. And honestly, I can't complain. Enjoy the mountains, watch the trains, but the cowbells are driving me insane. Jingle, jangle, oh, dingle, dangle, the cowbells are driving me insane. Jingle, jangle, oh, dingle, dangle, the cowbells are driving me insane.
Okay, well, you can see I got a little confused here. So I'm kind of blending multiple levels, and I realized at some point that I was starting to handle stuff that's a little bit higher than I wanted. So I was like putting queuing in to handle multiple messages, but really when I'm simulating one SPI transaction, I'm only thinking about one single message transaction at a time. So you can see kind of in the code that I wrote before, I had like a vec deck going for a while. And then I realized I just need kind of like one message because I'm also simulating kind of like DMA and things like that. So I do have a little bit of shenanigans going on here to simulate like an asynchronous DMA transaction that could happen. So there's a couple places where I thought I was just going to be able to shove messages in there. Oh yeah, that was another thing, is before I had incoming messages and outgoing messages, but actually I really only have one. So I'm either going to like get ready to send some data, or I'm going to have received some data already and I need to simulate that a little bit. So I've kind of changed things up with that. I'm almost done with the arbitrator, at least at the low level. I need to figure out this abort exchange, which I kind of know what I'm doing for that. And then I need to go do a client, and then I need to simulate kind of a quick high level implementation of that to make sure that sending messages is working as expected. But I'm going to go grab some late lunch, early dinner now. So I'm going to totally drop off the stream here for maybe like 20-30 minutes. I'll keep playing music. So if you just like the music, you can hang out. Otherwise, I'll be back at probably 40 past the hour, wherever you are. It's 5:40 for me. But yeah, I'll be back in, like I said, 20 or 30 minutes, and I'll pick up where I left off. Okay. Thanks everyone for watching, or if you're still watching. But yeah, I will be back in a bit. progress. It's now able to send messages, which is nice. Yeah. Basically, it's actually doing communication now. So they're simulating essentially a full transaction, which is nice. I'm starting to think that some of this needs to be laid out differently. So there's some of this logic, like what the sequences of ordering is, that really the user shouldn't have to choose. Like, because otherwise I'm relying on everyone implementing things correctly. I'm trying to think, like, especially some of these, like triggering an exchange or something like that, feels like it should probably be moved up a level, either to the high level or introducing a medium level or something like that. But I'm not 100% sure. Like, I don't have a totally clear view of what the data flow should be. Because there'll be a couple places where it's like, okay, data's ready, but now you need to copy it somewhere where it needs to be, or here's the packet or something like that. So I'm not immediately in love with it. But it's enough that I can start maybe building a high level stuff over it as well. Yeah, we'll see. I'll do a commit, and I'm probably, so let me go over the code that I've written, because I haven't really done a great job of explaining. So I've got these two. I've got the arbitrator and the component, and essentially, as you can see here, they're talking to each other, and I'm also printing out every time that they change the state. They do it really quickly because it's every 10 milliseconds they're polling. So I mean, like, the latency's no more than 10 milliseconds. But yeah, essentially what they're doing. So on the arbitrator side, we get a connection. We say that it connected, and then we just process messages in a loop. So this is essentially our event loop. Then let's see, if there is no exchange active, then what we do is we say, okay, check if the component has marked the ready line as active. And if it has, then we go, okay, it's time to start exchanging data. So we prepare the exchange and trigger the exchange. I think from the arbitrator side, there may not actually be any difference, because when you're a SPI peripheral, you don't really get to choose when you start. So you really just trigger the exchange. So I may actually remove that method. Actually, I think I'm going to go ahead and, well, I'll do that after this. But I think I'm going to remove this method. Remove arbitrator trigger. It doesn't get to choose. Because it's basically, it's going to go as soon as the controller starts clocking it. So this probably goes away. So once we've gone, now we'll have the exchange be marked as active, which means we're just going to continually call complete the exchange and mark the ready line as low, which means this would be like the callback you would probably get when a SPI transaction completes or the select line goes low or something like that, where you would complete the exchange. And yeah, so like abort, you'd probably call if the ready line fell low. Otherwise, when the correct number of bytes have been transferred. I'm trying to think how the arbitrator would know that a transaction is done. Probably once the expected number of bytes have been transferred. So probably, yeah. The other thing I should be doing is when you complete the message on the component side, it should check whether the ready state is still active. And if not, then it should someone ping me. Who's pinging me? Ah, never mind. Yeah. So I should probably check. I'm wondering if I'm going to have that problem in a bit. See, this is like that logic of when you complete the exchange, you should check whether the stuff is done yet. In the arbitrator, when do I send whether, when do I deassert ready? I guess it's when I complete the exchange. So it might be a little bit racy now. Like, for example, in complete exchange, I should let's do it as quickly as possible. See if that actually still works. Probably it's sort of racy because, yeah, but normally the arbitrator wouldn't hang up unless, yeah, I guess I can implement that. On the arbitrator side, it would be the arbitrator wouldn't typically close the stream immediately. Not arb dot what is the, oh, sorry, arb dot here go. Now I actually shouldn't have to worry about it, but probably at like any point. So we don't clear go here. We'll do that in the next loop. Woo! Let's make that level triggered. Go is now true, but we're never setting it low. Am I not setting ready low? Why does that not happen? Because I never actually clear go, because I don't see clearing go. I immediately prepare for a new transaction. I guess if ready is active, ready is now false. No, I do get ready. Payload got ready. Oh, it's because ready's already ready. Because I'm immediately preparing that. So I should actually abort. So here I should actually, if not, if not, then when do I start the exchange again? Okay, if not is ready, then we do arb dot or exchange dot okay. I think this always clears go. If not is ready active, because then we shouldn't have started one anyway. Woo! Main 37 is ready active. If it's just trying to check before the device actually initiated. Go is now false, 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 false. Done something wrong here. Let's see. So if no exchange is active, if ready is active, prepare the exchange and trigger it. Clearing go, which means the next time did I say clearing go a bunch of times? Why did it get the go state a bunch of times? If not exchange, if arb is ready active, then we trigger one. Else if go state, we clear go. Does clear go actually? Yes, it does. No exchange is active up here. If there is an exchange active, if is abort exchange not update that? No, it does clear it. But I sort of expect that to fail. Why are you failing? Why does it send? Why does it send that like 1,000 times? Go state. Notify go. Clear go. Trigger exchange. Because it's not saying clearing go like 1,000 times. Am I not popping a message or something? Like I'm getting the message over and over and over again. Why? Got ready, start exchange. Ready is now false, which makes sense. I don't understand why that's looping over and over. If I send messages, I guess it's it all. Okay, so you are clearing it. Why are you clearing it? I bet you it's immediately starting a transaction. Should I probably, else if is ready active. So, but we only do that if ready is active. State. So what if I do something hacky? Okay, well, apparently I found a bug and I need to figure that out. So I'm going to go back to working. So just real quick, I realized what it was. The problem was when I was aborting the exchange, I copied and pasted the code from completing the exchange, which would try to recover if there wasn't something to complete, whereas I needed to continue. Yeah, basically in abort, you shouldn't try and recover. So it was basically trying to recover as if it was complete exchange, and oops. But yeah, I sorted that out. So I fixed that in both of those now so that they don't try and recover. So you can see like here, it would go, oh, there's still a pending exchange, even if there was no data yet. But in abort, if there's no data, then cool, we just say, okay, we didn't exchange anything. Yeah, so let me finish explaining how all this works. So, and I promise I won't get distracted this time. Yeah, so we wait for we're in our event loop. If no exchange is active, then we check if ready is active. If ready is active, then we start the exchange and we immediately prepare and trigger it. If it's not there, then we say, if we've currently said, okay, but we're going right now, then we immediately clear the go that says, oh, okay, we've noticed that the client no longer is interested in sending data, so we'll stop. And if we haven't gotten that data, or if go isn't active right now, then we just do nothing. So this is basically like the idle waiting. So basically we're just waiting for ready. Otherwise, if we have an exchange active and the ready line goes low, then we abort the exchange. So this is saying like, oh, well, that didn't go, so let's not mark ready anymore. This is basically like the client or the arbitrator acknowledging the client's hang up, more or less. Then we check if we can complete the exchange but don't clear the go state. This says if like the client wanted to send 2 messages in a row, then they could without like totally restarting the process, which will happen sometimes. Because I'm going to end up doing kind of like a 2-stage thing where I send the length and then I send the payload. So yeah. So now I have and then yeah, if it was complete, then we completed it. And over on the component side, we have pretty similar, but the logic's a little different. So essentially on the client side, the way the flow goes is we process. If we currently have an active exchange, and we haven't triggered the DMA transaction, and the go line is active, then that means, okay, it's time to start exchanging data, because yeah, the client is usually the one that, or the component is going to be the one driving the transaction. So they trigger the exchange, and this would normally probably be an interrupt, but yeah. Otherwise, this means that either go if not triggered. So I should probably, just for the sake of correctness, do if because if it has been triggered, then we try to complete the exchange. If we get an error, whatever, keep trying. If the exchange is completed, then we look at the data, and yeah. So here's where we'd probably like push it into a queue or something like that. Not 100% sure. Otherwise, if no exchange is active, then we just look to see if it's been 3 seconds, because essentially this is modeling a device that's sending messages every 3 seconds. And then we start the exchange, we prepare it, and then essentially we wait for so this is setting ready, and then we wait for go to be active. So this is like the two devices being triggered. Yeah. So now what I need to do is, if I'm going back to my notes, so I have most of this done. I have the low level interface. Now I need the high level interface. Yes, I don't know. Yeah, I guess it's still here. I have the low level interface working. So now I need to get the high level interface working. Yeah. So I'm gonna keep doing that. Actually, I'll probably go take a quick break now. I'm thinking about getting some coffee. So I think I'm gonna go get some coffee. So I'm gonna go do that. So yeah, I'm gonna go do that, and I'll be back. I'll say hey, and then yeah. So I'll put the music back on while I'm gone.
In all the world, there's only one girl like you. There's no one else who does the things you do. Who dances in the light, full of color, though black and white. No other one like you. Oh, Bella. Oh, Bella. Oh, Bella. Oh, Bella. crystal blue. Ooh, a half moon for a face, not one spot out of place. A perfect sleepy muse. Oh, Bella. Oh, Bella. Oh, Bella. Oh, Bella.
Okay, so I'm at the point, so I have the arbitrator working, and it now is actually sort of doing this send a header, send a payload kind of dance that I was planning on the protocol doing, which is good. I haven't used the high level traits to do this because I realized I sort of want to figure out what the interface should be. Some of this I feel like I said, should be in the trait. Some of it would be hard to put in the trait. Like 80% of it should go just in the trait impl. Which means I might need to actually break this out, figure out what methods wouldn't go in the trait impl, and then move those out and make that the actual implementation, I suppose. Yeah, I'm not 100% sure how I'm going to organize this, but I'm going to get it working before I actually organize it in case I have to radically change things. So what I've added here is I have now a high-level arbitrator structure that contains a low-level one. It's got incoming and outgoing queues, so this pretends to be the arbitrator, and if the arbitrator queues up a bunch of messages for the component, or if the component sends a bunch of messages in and the arbitrator doesn't process them super quick, these would go in a queue. The out buffer is used when I'm not popping a message from the queue. Mostly this is the header, like the size header of what the next message should be. This probably could be like a fixed sized array of 4 elements rather than a vec, but yeah, that's probably fine. The in buffer, you probably, like if I was doing this with BBQ, I'd replace both the vecdex and then the in buff wouldn't matter because yeah, the in buff wouldn't matter because I'd just be using like the next grant. I'd be using like a BBQ grant. The reason it's an unsafe cell is because it's been an unsafe cell the whole time, but it's because I'm modifying it through a pointer method. And I need this to not be unsound behavior. So it's unsafe, but it's not unsound currently. And right now I have a flag that says whether we've sent the header yet, which is basically ping-ponging between sending the header and the body. I think I probably want to make this like an option size or something like that, but I haven't yet, and I don't check any of that yet, so it's whatever for now, but I'll probably clean it up at some point. So you just create it by creating a new one. It's got a method for dequeuing incoming messages, enqueuing outgoing messages. And then poll is basically the loop that was there before. I fixed a little bit of the logic error, but some logic errors, but the biggest difference is now when you're sending, it ping pongs between these two behaviors. So if you haven't set the header, then it figures out what the size of your next outgoing message is, or if there's none, then it just says 0. So you get 0, which is the front message, and then you either get the length or 0. Then, because right now I've said it's going to be a U32 on the wire, I clear whatever was in the buffer before. I put those 4 little endian bytes in there. I set up a new exchange where I use the out buffer, and then I'm going to be sending 4 bytes, and I also know that I'm going to be receiving 4 bytes here. Otherwise, if we've already sent the header, then this is like the pong of the side. So this is now the other side of it, which is, are we going to be having an outgoing message? So here we try and peek at the current outgoing message. I wonder if this is on sound. I wonder if VecDec can reallocate if you push to it. This is probably on sound. It works for now, but that's probably because I'm not doing anything fast enough to corrupt anything. Well, I'll come back to it. And then we prepare for the exchange. Again, right now I'm just giving it the max size of my buffer, not the size of the header. Really, for sanity checking, it should be the size of the header, but what are you going to do? Yeah, I've also fixed while I was coding in there. I figured out, I think in the client, there was some problem with, I was checking in the wrong place. So it was actually terminating the messages all of the time, which was bad. But yeah, other than that, most of this is the same. If we're in the Pong, then I pop a message off the queue if there was one. And then we just alternate back and forth. What I probably should do is copy this message into the VEC so that I know that I have a stable location. I need to look at and see whether VecDec reallocs. I don't have a browser open, but yeah. So that's working on the arbitrator. My next step is going to be, I'm probably going to give the component the same treatment, like switch it over to a high level interface. And then I think I'm going to be done for the day because it's like 8:30 here and this has been a pretty good day. I may still work on this off the stream, but it's probably enough recording for today. Yeah, I managed to sit here and let my coffee go cold because I was so caught up in this, but okay, well, I'm gonna hop back in and work some more. And if I hit any roadblocks, then I'm just gonna stop for the day. But hopefully I can get the component switched over like I did the arbitrator, and we can get kind of a couple of round trip high level messages going back and forth. I'll be pretty happy with that, and then I'll call it a day. And then tomorrow I might actually stream a fairly large chunk again too. Probably continuing to polish this and picking up the stuff that I didn't get to today. So some of the actual real hardware stuff. But let's see if I can get all the simulated stuff done today. And then I'm pretty happy with that. So back to work. Okay, well, I got it working. Yeah, it was a lot of copy and paste from the server code or the arbitrator code, and yeah, there's a little bit of change just to, so in particular, the client isn't gonna wait around for the arbitrator. It's just gonna decide when to send. So basically, if it ever has a, let's see, where is not exchange is active. So, if we have an outgoing message ready, it starts doing that same ping pong header thing, where if we haven't sent the header, then figure out the length of the uh, outgoing message. This one doesn't need to send 0 because it just won't send it. Although in the future, I should probably poll preactively or proactively. So just even if there hasn't been a message in a while, just say, hey, arbitrator, do you have any messages for me? Because the component is initiating all of the messages here. But I'll do that later. um, so yeah, it just sends a message, and then once it after the header's been sent, it'll send the body. If the message is started, it waits for if checks whether it's been triggered yet or not, and if it hasn't been triggered but the go is active, then it says yes, it's time to be triggered. Yeah, basically, if the go line ever goes false after we've triggered, we abort the exchange. Otherwise, we try and complete the exchange. And if we got a non-zero message, then we put it in the incoming message queue. So from a really high level, I've got the component is idle. Component drives the, drives the ready line low. Component waits until the go line is low. Component sends 4 bytes, so they each send the size of their next message, or 0 if there is no message. The component decides whether to continue. Right now, I always continue. Yeah, it could release, but this would be like an error case. Otherwise, the component checks if the go line is still low. If not, the component releases the ready line high and returns to state 1. This happens by basically if we've ever triggered and the line is not high, then we'll bail. Component clocks up to max. I haven't really, because this isn't real SPI, I haven't actually done any like, oh, how many bytes do I clock? But that's okay. We're technically doing that now because we're just sending packets. And then the component decides whether to continue. Right now, after sending each message, it just releases the line. I probably could do, immediately check if there's another message, and if so, run through again. But this is the high level behavior. We've got both of these layers working now. So the next step is to start encoding data again on top of this and putting it inside of our application. I wonder if I need to reframe this, because I actually have framing provided by the well, I guess I'm going to be encoding the data, but it's not going to be COBS encoded at this layer. So that's actually good. I'm not going to be double COBS encoding like I thought I was. So this is just like a data format. The rest of it is mostly plugging into my existing Anachro-PC. So this is like the stuff that's in client, ICD, and server. Well, ICD is the stuff that lives here, and then this is the information from the client and the server. So we're like a third of the way there, and I've already written this for other transport layers, so I'm actually pretty pumped about this. I guess probably should replace my other PC examples sending simulated SPI instead of just like regular. What I was doing before is essentially just this, more or less, because I was just COBS encoding data over TCP stream. I wasn't emulating any of these like ready go lines. But yeah, it's all working, and I'm pretty pumped about that. Let's clean up some last errors. So we're in component 204. I can print that. I just disabled all my prints, so I did get quite of a messy output. Okay, So now we've got this. So now I can do a quick demo, and then that's going to be it for the day. So I start the server, and then I start the client. They're sending at different rates. The arbitrator has something to say every 10 seconds. The client has something to say every 5 seconds. So you can see it enqueued a message, and we received that message over here. Then the arbitrator decided to queue a message, and you can see that it showed up over here. So we got 6 bytes from the arbitrator and 9 bytes from the client, which matches kind of in my super high level control loop for each of these. So the arbitrator every arbitrator every 10 seconds will send F0, which is 240, 6 bytes. And then in my client, up in the control loop, every 5 seconds, it'll send F, which is 15, and 9 bytes of it. So we see this is actually working and communicating, and they're actually negotiating pins, or they're pretending to negotiate pins the same way I would do with SPI and GPIOs. So you can see it's almost exactly a 2-to-1 ratio here, which is perfect. So today was actually a pretty productive day. I'm super excited about this kind of format. I actually will probably do this more, and I will probably do a version of this edited down. So if you're watching like a 30 or 45-minute video on YouTube, you are watching an edited version of this, and there's like a 6.5-hour long version of this on YouTube as well. If you're watching the 6.5-hour version and you're very bored, you could have just watched the 30 or 45-minute one, but I'm going to do some editing on this soon, and we'll see how this goes. But I really enjoyed this, so I think I'm going to do this format some more, at least try it out a couple more times. So I don't think anyone actually watched all 6.5 hours. There's no one actually on YouTube right now, but I'll just stream it, because then if someone really wants to watch the whole thing in real time, they can. Otherwise, I'll put up a separate one that's been edited, and you're probably watching that one if you're watching this right now. So thanks for watching either version of the video. Make sure you subscribe to my channel, and I'll talk to you later.